Pipe welding is a welding technique used to create a joint that connects two ends of a pipe or tube. Pipe welding is usually used to connect metal pipes, and these welding techniques are widely used in pipelines, gas and petroleum industries, architecture and other industries. Pipe welding can be performed in a variety of ways. The most common methods are TIG, tungsten inert gas, welding, MIG, metal inert gas, welding, and stick welding. These welding methods have different advantages and disadvantages of pipe welding, and can be selected depending on the size, thickness, and material of the pipe or pipe. Pipe welding is critical as a safety and quality issue. Proper procedures and equipment can be used to create secure and robust joints. Therefore, it is always recommended that you leave this task to a qualified professional. What about TIG welding? TIG welding, tungsten inert gas welding, is a contactless arc welding technology that uses electric arcs to weld metal parts. TIG welding uses antioxidant gas, typically argon gas, at the weld reference area to protect the area around the weld arc and to protect the weld from contamination. TIG welds enable very precise and clean welds and minimize oxides and other impurities from the welds, eliminating the need for recleaning or finishing after the weld is complete. For this reason, TIG welding is suitable for welding a wide range of metal materials, such as thin metal, non-ferrous metal, and aluminium, which do not require high-speed heat. TIG welding is an advanced welding technique and can only be trained and practiced properly. In addition, active safety measures should be taken during TIG welding. For example, proper protective equipment, safe working conditions and adequate ventilation of welds are required during welding. What about MIG welding? Metal inert gas welding, MIG welding, is a welding technique for welding metal parts using electric arcs. MIG welding provides protection around the weld arc with protective gas, typically argon gas, while transferring the weld wire to the weld along with the weld arc. MIG welding makes welding easier and faster compared to TIG welding, providing high productivity and good welding quality. MIG welding is also a welding technique that can be acquired with relatively less training and practice than TIG welding. MIG welding is commonly used for welding steel, stainless steel, aluminium and other non-ferrous metals. Many factors affect welding quality, such as pre-welding pressure regulation, welding wire selection, welding time, welding speed, and use of protective gases. MIG welding requires active safety measures. Measures such as wearing appropriate protective equipment, creating a safe working environment, and ensuring adequate ventilation of the weld area are required during welding. What about sticky welding? Stick welding is a welding technique for welding metal parts using metal electrodes, typically rod-shaped electrodes called stick electrodes. In stick welding, welding is performed by creating an electrical arc between the electrode and the metal part while bringing the welding electrode into contact with the metal part. Stick welding is a welding technology that allows welding to be performed at a lower cost than TIG welding or MIG welding, making it easy to move the welder and able to weld almost any metal material. Stick welding has the advantage of being able to easily replace weld electrodes as needed and is suitable for outdoor work or in relatively small spaces. Stick welds generate electrical arcs, producing a small amount of smoke and impurities around the welds. Therefore, the use of adequate ventilation and protective equipment for stick welding requires active safety measures. In addition, stick welding may have a slightly lower quality compared to TIG welding or MIG welding, and acquisition requires some training and experience. The area you need to be careful about while welding. Welding requires active safety measures. The following points must be taken into consideration when working on welding. Wear appropriate protective equipment. Proper protective equipment, helmet, safety glasses, work clothes, gloves, safety shoes, etc. must be worn during welding. Create a safe working environment. Welding should create a safe working environment, such as fire prevention, adequate ventilation, and no electrical work around airplanes and industrial machinery. Cleaning welds. Cleaning welds directly affects weld quality and may not be properly welded in areas with impurities. Therefore, the welds must be cleaned before welding. Appropriate welder adjustment. Welding quality can be improved by appropriately adjusting the current, voltage, speed, etc. of the welder. You need to understand how to operate the welding machine. Proper use of protective gas. TIG welds and MIG welds should use protective gas, typically argon gas, to protect the weld arc surroundings. Appropriate post-welding. After welding, the welds must be cleaned and post-worked as necessary. Ventilation and exhaust systems. Suitable ventilation and exhaust systems must be in place as welding will produce smoke and impurities. This is important for the health and safety of welders. Identification and remediation of defective welds. Defective welds may occur during welding. In this case, you should check and deal with it immediately. If the defective welds are left intact, this must be taken as problems may arise later. Posture of the operator. The position and position of the operator are also important when working on welding. This directly affects safety and welding quality. Therefore, proper posture and position should be maintained during welding. Inspection of machinery and materials. Welding operations should also check the condition of the machine and materials. If a machine malfunction or material defect is found, this should be taken immediately. If welding is carried out with these considerations in mind, safe and effective welding is possible.